Hello, Virtual Academy, welcome back. Moving on, function equations, Unit 8, Algebra 1. We already found out that we can use equations to represent many functions, right? Obviously, for this chapter, we're talking about linear equations. And as you can see here in your manual, you will be able to, go back and refer to all these examples here in your quest to conquer everything that could be learned in this lesson, right? How about some problems here that we can discuss, we can solve together, we can get better at, right? By more practice. How about problem number 2? Use function notation to write the equation of the line. What can we do? Obviously, and I hope all of you noticed that this is linear. It has to be a linear equation because we're dealing with a straight line, right? X and Y axis. As you notice, there are 2 points plotted on the line. Okay, what should be the first step? And blue will do it, huh? Well, I will use the slope-intercept approach, right? The slope-intercept form of a linear equation, which says that y equals a number m times x plus b. M would be my slope, right? B would be what? Your y-intercept. Can you find any one of them right away? Sure you can. Y-intercept. Y-intercept is what? Well, the point where your line crosses the y-axis, that point is 0. So I will know for sure that b, the y-intercept, equals 0, which cancels out in your equation any other number except the two variables, right? The terms with the 2 variables. Now, let's find m. Let's find our slope. Many ways to do that, right? One way is to remember that slope is rise over run. Okay, rise over run. Let's label this point A, the other point B. To find the slope, you need to find how many units are you going up from A to B and left or right from A to B. Well, right in this case, so it will be up and down, left or right. Obviously in this case we're going up, and I will use a different color for about red, right? So from A to go to the B's altitude will be 1, 2, 3, 4, 5, 6 steps, right, into the positive direction of the y-axis. And then from here I have to go 1, 2 steps to the right. That's my run, positive 2. Now we could have stated from the beginning that the slope has a positive sign, that the slope of this line is positive, that this line has a positive slope, right? And to find the slope, all we need to do next is to substitute the values of my rise, hopefully a raise too, right, for the teacher, why not? So it'll be 6 over the run, which is 2, and this gives you a slope of 3. Alright, now next step, plug it in. The equation will be y equals 3x, but we have to use function notation, right? It says right there in the problem, use function notation, which means instead of y, you will state a function of x. F of x equals 3. Okay, done. I hope it makes sense. Okay, page 301. We need to evaluate each function for the given values. Which one would you guys like to solve? Eeny, meeny, miny, moe, right? How about number 10? T of x equals negative x minus 2. This is our function. It's a function that is called t and is t of x, right? X is your input and the output will be your y's, you know, whatever transformation x suffers, the outcome will allow us to find and evaluate the value of the function for that given input. Okay, easy, right? T of negative 4, this will be equal to whatever you have x into your function, you will plug in negative 4. Now be careful, right? Because your function is negative x, but now my x is negative 4, right? Negative 4 minus 2 equals 1. Well, negative 4 or minus 4 if you want, when you subtract, you change both signs. Or you have a minus outside the parentheses, that's equivalent to a negative 1 multiplied to everything inside that parenthesis. And now your problem is 4 minus 2. That's a tough one, right? That would be 2. How about the next one? T of 4. Well, I have negative x. Well, I'm going to use parentheses just to show you guys the substitution. So instead of x, I'm going to put 4, right, in here, minus 2, which equals what? Well, minus 4, or negative 4 if you want, minus 2. We said when you subtract, you change both signs, right? So this would be plus a negative 2. I have a negative 4 plus a negative 2. 4 negatives plus 2 negatives. The rule says add their absolute values and keep their sign. Negative 6. And we're done. Okay? The value of the function for x equals negative 4 is 2. The value of a function of this function for x equals 4 is negative 6. Similarly, you can solve all the other problems in this category. Any questions? Let me know. Alright, problem number 26, right on the next page. The graph below shows Layla's driving speed over a 5-minute period. Part A. What was her speed after 2 minutes of driving? How about after 3 minutes? Part B. During what time periods was she decelerating? Pretty much braking, right? Everybody knows what decelerating means. Let's start with part A. Part A. What was her speed after 2 minutes of driving? How can we find it? Well, we have a graph, right? And in this graph, the x-axis represents the time in minutes, right? In minutes. Y-axis represents the time in, not the time, the speed in miles per hour. Okay? The question says, what was the speed after 2 minutes? Well, Lila's driving speed over 5-minute window is represented by this graph. Okay? So in my graph, I'm going to find the 2-minute point, which is right here. And from this point, I'm going to construct a vertical line, right? Which obviously, as you guys can see in here, intersects the graph in this point, right? Let's call it A. To find the speed at this point in time, of Lila's car, I suppose, not Lila's bicycle, right? I have to go with an horizontal line from A, which, as you can see, intersects my speed axis, my y-axis, which represents the speed, right? Well, not my speed, Lila's speed, at the point with the value of 50 miles per hour, okay? And this will answer your question. 2 minutes into the driving, Lila is moving with 50 miles per hour, okay? How about after 3 minutes? And green will do it, right? After 3 minutes, same approach. I'm going to the point on the time axis, right? The x-axis in this case with the value of 3. And from this point, I will construct a vertical line. Let's make it what color? How about that one? Well, yeah, I hope you guys can see it right anyway, right? It's gonna be about here. For some reason I keep moving it to the side. But anyway, this is my point, right? From this point, as in the previous problem, I'm going to construct an horizontal line, right? An horizontal line parallel to the time axis, to the x-axis, and wherever that line intersects the speed axis, that will be the speed of Lila's car, motorcycle, bicycle after 3 minutes, right? What is not there is here. Okay, that's about how many miles per hour? Well, here's 45. Halfway between 40 and 45 would be 42.5. 42.5 miles per hour, and that will be the answer, right? 42.5 miles per hour. Okay. Question B. Question B. During what time period was she decelerating? Okay. So I'm looking on my time axis, on the x-axis, for what intervals Lila is applying brakes. Okay. Now, as you can see in this graph, we're definitely talking about a time window, a time frame, a time interval here where Lila was already driving, okay? Because if you'll have Lila starting to drive her car, then the miles per hour speed should have been originating from 0, right? I mean, you're stand still and you start moving your car, your speed is 0 and increases as you move, right? But in this case, she was already driving 60 miles per hour. And all you have to do for this is to look on the graph for portions of the graph where your speed goes down, right? And as you can see, I have two of this situation. One is here, right? For this interval, as you can see, the speed goes down on this line, right? And this is the time from 0 to 1 minute, right? 0 to 1 minute. And then I have another one in this window here from 2 minutes to 4 minutes, right? So we'll have 0 to 1, I'm sorry, 0 to 1 minute, and 2 to 4 minutes. their speed. The car speed decreases, so that's most likely a decelerating part, right? Okay, this is it for today. Go for it, take the quiz. We'll see you guys tomorrow.